This lesson is on alternative energy sources. So, why do we need alternative energy sources? Materials that are burned for heat or power are known as fuels. These include wood, coal, brush, fecal material, peat, etc., so on and so forth. We use a lot of fossil fuels, those non renewable fuel resources that cause multiple types of pollution. They cause um, carbon dioxide emissions, which contribute to global warming and problems associated with global warming. Oftentimes, they contain sulfur, mercury, and other harmful pollutants. Burning fossil fuels also negatively affects air quality. So, we really want to stop using the fossil fuels. And just to make this point more robust, fossil fuels, even if they didn't cause all these problems associated with global warming and pollution, we still would need to find alternative energy sources because fossil fuels are non-renewable. They're going to run out eventually if we keep using them. We're not going to have them anymore, and we're going to be left without a way to power everything that we've created that helps us live a more comfortable life. So we've got to just it really shouldn't even be an argument. I know it's often a big political fight whether we should keep going with fossil fuels or go to alternative energy, but it really shouldn't be. There's really no other way. We've got to start switching over to uh, alternative energy, and we need to diversify as much as possible. Okay, so alternative energy sources, as we seek them out, we need to try to find these sources that are renewable. You can do them over and over again, and they won't run out, and they also need to be better for the environment. And that's where we have to be careful. Just because an energy source is an alternative energy source doesn't mean it doesn't have its own set of problems. So we need to try to find the best energy sources, the ones that create no problems or the least amount of problems. All right, so scientists have developed energy resources that are an alternative to fossil fuels. They reduce those harmful emissions and those pollutants. But here's the thing, they're not always sustainable, meaning they're not always something you can keep doing in the future. There may be some problem associated with them where, it's only a temporary solution. A lot of the ones we're going to talk about today, some of them, they could definitely be a permanent solution, and others, they might just be something that we're doing as we, shift from fossil fuels to other energy sources. So, the ones we're going to talk about today are solar energy, wind energy, hydroelectric energy, geothermal energy, nuclear energy, biofuels, and fuel cells. All right, solar energy. Photovoltaic or PV panels convert sunlight into electricity. They're commonly used on mountains, roofs, and in deserts. We don't like to use them on the coast because they can be damaged by hurricanes. And these photovoltaic panels, when they're created, we really want to keep them in use. And we'll talk about why in a moment. So we don't want them getting damaged. All right, advantages to solar energy. It is renewable, right? As long as the sun is shining, you're producing energy. It's clean. It does not result in any pollutants. It's quiet. It doesn't cause any noise pollution, and it's inexpensive to operate. Now, disadvantages. It must be used in open areas. There are definitely areas that are not suitable for solar energy because your panels would be somewhere where sunlight doesn't reach them like it needs to. Also, solar energy depends on sunny days. You have to have sunny days. If you have days that are too cloudy and not enough solar radiation is reaching the panels, you're not going to be making enough or any solar energy. Also, they don't work at night. Now, they are expensive to produce and to install. They're made of silicon, and you have to purify the silicon, and it takes a lot of energy to melt down the silicon and remove the impurities. So, the thing about solar panels, you want to make sure that they last a long time and that you use them long enough that they offset the energy that was put into creating them. You want to keep them things in use for a very long time, and they have to be used for a good while before they offset the energy that was put into producing them. So you want to produce solar panels that are strong and durable and can be used for a very long time. And we have some examples of solar panels here. These are some of the more sophisticated ones. Some of these will actually track the sun as it goes across the sky during the day and maximize the efficiency of these panels. All right, wind energy. This uses the energy of wind to turn a turbine, which generates electricity. These are best for coastal areas, mountains, and open plains. The advantage is that this is renewable energy. You're not going to run out of it. The wind's always going to blow at some time or another. And that's one thing about these. You need to put them in a place that has, reliable wind. You're going to have wind often, and it's going to produce plenty of electricity for you. You don't want to put it in a place that doesn't get a lot of wind. This is clean energy. Doesn't produce any pollutants. And it's somewhat quiet. In areas where you have a lot of these windmills, you're gonna, you can incur some energy. It makes you're gonna incur some noise. It makes a pretty loud whooshing noise if you have a lot of them together. This has a little impact on ecosystems for the most part. Now, some disadvantages. Like I was saying, the wind has to be blowing or these don't work. Nothing's happening if the wind's not blowing. So you want to install these in areas where, wind is almost a daily occurrence. Plenty of wind, predictable wind patterns that are going to move these turbines very, very often. High production and installation costs. Yeah, they're not cheap. They're pretty expensive to build and then install and maintain. They can take up a lot of space if you have a lot of them. You can work around them some. You see here, this one's on a farm, and they're doing some farming right around the windmill. You can't really build these in urban areas. In the city, there's too much. There's too many things that can block the wind, and the wind doesn't have reliable. You just don't have as reliable wind pattern. You have skyscrapers and large buildings and trees and other things that can just disrupt the wind. So these are not all that great for urban areas. That may change in the future with some advancements, but as of right now, not that great for cities. A big problem with these in terms of environmental impact is that they often kill birds, and this includes eagles and condors and some of these are endangered species or threatened species, and we really don't want to lose any of these birds. But sometimes they have a hard time sensing those blades and even knowing that they're there, and they fly and the blades hit the birds and kill them. It's very unfortunate. So we need to try to find a way to avoid hitting birds with the windmills. So here we have a map of North Carolina, and this is a map showing what areas are suitable for wind energy and which ones aren't. As you see here on the legend here, white is very poor. The areas colored white indicates an area that is very poor for wind energy. And if you notice, that's pretty much the whole state except for offshore here on the coast. Here we have some quite suitable areas for wind energy, but it's all off the coast. But this can be done. You can have these windmills or turbines out on the water, and they will work very well out there. So hopefully this will be something we develop in the future to help meet our energy needs. All right, biofuels. These are energy resources that come from living organisms. Biomass is material left over from a once living plant or animal. We're talking about parts of the plant or animal bodies. And some of this can be used to produce bioethanol and biodiesel. Certain parts of plants can be used to produce bioethanol and biodiesel, and then fat from animals, like leftover waste fat from animals, can be used to produce biodiesel as well. Now, whether certain biofuels are sustainable and clean or not depends on the source of the biomass. Some biomass produce cleaner and more efficient fuels than others. Corn for ethanol production is currently grown in the coastal region of North Carolina. Now, there are some problems with purposefully growing crops to produce biofuels. And one is a lot of the biomass that we use for bioethanol um, is food otherwise, and you're basically taking um, food away and using it for something else, and really that's not a good idea to be doing. That's a little bit of a risky practice. Also, you have to make sure you're not putting more energy into producing those crops that are going to end up making ethanol or biodiesel than the bioethanol or biodiesel can produce or is worth. For example, you can end up using more resources producing the biofuels. Like farm machinery, a lot of it still runs on diesel fuel and other fossil fuels. So if you're producing corn to make bioethanol, but you're using a lot of fossil fuels in its production, you're kind of defeating the purpose. So in general, it's better not to raise crops specifically for biofuels. It's better to find waste material that's suitable for making biofuels. That's the best practice, because waste material that's left over and has no other use, that's the best thing, because you're making use out of something that otherwise does not have a use, instead of taking something that has a very important use like feeding people and using it for something else. If you watch the videos that I'm going to post on biofuels, they explain a lot about the problems associated with producing biofuels and how the way biofuels are produced can actually make biofuels more harmful than helpful. So biofuels do have a helpful potential, but we have to be careful about how they're produced. And also this might be one of those ones that this might be one of those alternative energy sources that proves to not be sustainable. This one might be just kind of transitory, or this might be something we use for a limited amount of time while we switch to even better sources. Advantages of biofuels: they're actually less expensive than gasoline. They don't put out as much carbon dioxide emissions than gasoline. Now they do put off carbon emissions when you burn them. We're talking about once living things that we've made fuel out of, and carbon's a big part of that. All living things are made largely of carbon. So when you burn these fuels, it's going to release some carbon, but it's less carbon emissions than gasoline, so at least it's a reduction. And biofuels are considered to be renewable. You can make more of them in a reasonable amount of time. Disadvantages: they have lower energy output. All right, the same amount of gasoline is going to create more energy than an equal amount of bioethanol or biodiesel. Like I was saying earlier, it takes a lot of land, water, farming equipment, all the stuff to produce new biomass. So we might actually be more wasteful in producing these biofuels than by not producing the biofuels. And like I said, it all depends on the process. And then the videos that I'm going to share with you, they're going to talk about ways that are not sustainable and more harmful than helpful, and then they're going to talk about other ways that are a lot more helpful, such as using beef tallow, or using the plant oil that's left over from fast food restaurants when they're done using it, the cooking oil that can be used to make biofuels, and otherwise it would just be discarded. So there is a right way to do biofuels, but like I said, this may just be something we do for a while as we're transitioning from fossil fuels to sustainable, renewable energy. All right, nuclear energy. In nuclear fission, uranium or plutonium atoms are split into smaller atoms to release heat and energy, and we use that to heat water, and it's pressurized and turns turbines and creates electricity. We've talked about this one in the past. Advantages of nuclear energy: it's very reliable and it's cleaner than coal. It does not produce any particulate air pollution. So there's no carbon emissions, there's no sulfur, there's no mercury. It just doesn't pollute the air. However, it's very expensive to produce and maintain these plants. The process of nuclear fission, we've talked about in the past, produces a radioactive waste that has to be stored and monitored for 10,000 years. I mean, based on the half life, I mean, we're pretty certain that for 10,000 years that waste is hazardous. So we have to store it and monitor it for 10,000 years, and that's just, I mean, that's just kind of frightening to think about something that's dangerous for that long and that we're going to keep producing it. So, um, hopefully we, you know, find other ways of making our electricity. There's also a threat of meltdown. This has happened before at 3 Mile Island in Chernobyl and Fukushima. We've had the failure of nuclear power plants, and then you face nuclear meltdown, and radioactive, just radioactivity is released into the environment and harms anything it comes into contact with. Also, there's the threat of nuclear terrorism. Nuclear power plants could be a big target for somebody that wants to do a lot of damage. And also, the same materials that go into making nuclear energy also go into nuclear weapons. And, there's a lot of countries in the world we'd rather not have access to nuclear weapons. All right, fuel cells. So these convert chemical energy from hydrogen into electricity. These are still in the research and development stage right now. They're really expensive to produce, and we're really not anywhere near mass producing this. Now, if we could, this would prove dependable, renewable energy source. The only byproduct is water, so that's good. You're not producing any nasty pollutants by running fuel cells. But the disadvantage is, like I say, that they're very expensive right now. They're still in the research and development phase. This may not be something that we can get to be compact enough and efficient enough to, and inexpensive enough to mass produce and use commonly, but maybe so. Another problem is that it's difficult to obtain the pure hydrogen that these run off of. All right, hydroelectric power. So electricity generated by flowing water we refer to as hydroelectric power. So usually there's a dam and water flows through the dam, and this turns turbines which generate electricity. And this is a lot cleaner than a lot of ways of producing electricity. The advantages are you're not using fossil fuels, so again, there's no carbon emissions, there's no air pollution at all. It's a reliable way of making energy as well. It's renewable, and as long as you have a river that will flow, you've got a constant source. Disadvantages is that it disrupts natural ecosystems. When you dam a river up, you keep organisms from moving up and downstream, and some need to do that in order to reproduce. Also, you're keeping nutrients and sediments and things that need to be moving downriver from moving downriver, and you might be depriving ecosystems from nutrients that they need. Also, behind the dam, and when you're holding water like that, it can heat up too much sometimes, and that can cause problems for organisms living in the water. These are also quite expensive to build, and they're heavily regulated by law. There's a lot of laws about how you run these, how often you can run them, and it just can be kind of a detriment to producing electricity. So as of now, this is a pretty common way of making electricity, but that may change in the future because we've identified a lot of environmental issues associated with these. So this one might be another one that may go to the wayside because it is not necessarily sustainable. Wave power. This is a form of hydroelectric power that is derived from the motion of the waves. So this makes use of the natural movement of the waves. And if you've ever been to the beach, the waves never stop. It's a 24-hour thing. The waves are constantly moving. So if we have if we can harness the energy of these waves and produce electricity with it, that would be great. Now the picture you see here has kind of like the aquatic version of the windmills. I haven't seen any real world examples of this kind of thing, but what I have seen is an apparatus where you have an arm coming out from some kind of um, building or other structure, and then it has a floating kind of I don't know how to describe it, like a disc attached to it. And so when the waves move, it moves this arm up and down, and also it pumps water into the system and pressurizes the water, and that water gets sprayed on a turbine and it turns the turbine, and that produces electricity. That could be a real big energy source for the future because it does not pollute, it does not heat the water in any way, and like I said, the waves are endless. The waves are always going. So that wave power seems like a pretty promising source of energy for the future. Geothermal energy is a great one. We can utilize heat from within the earth to heat water and make steam that drives turbines and creates electricity. The only problem with this is you can only do this near plate boundaries or hot spots, somewhere with volcanic activity. This is currently being utilized in Iceland, and they're very proud of this clean and more or less limitless energy source. And they indeed have the right geology for it. We've talked about Iceland in the past. It exists on a divergent plate boundary, and because of that, they have the volcanic activity to produce this geothermal energy. All right, advantages: it's clean and renewable. Disadvantages: it's an expensive initial setup cost. So it's very expensive to produce the plants and to operate them. But again, like I was saying with the solar panels, once you've set it up and you operate it for long enough, it starts to offset itself. In the picture here, you see what looks like a lot of smoke or some kind of emissions coming out, but that's actually just steam. That's not going to be harmful. That's not going to pollute the air in any way. So here in North Carolina, we unfortunately do not have the kind of geology that would support this. But future technology, may somehow enable us to utilize this method if we can, locate some kind of warm spot in the mantle below us and somehow access that heat. But that really doesn't seem likely. If you ask me, according to what I know, it seems like this kind of energy will always be, you just have to be in an area that has the proper geology for it, or you're not going to be able to use it. Now here we have an example of a geothermal reservoir. So we have like a hot spot here, right? This unusually hot part of the mantle, and you have magma under here, and it has heat, and it's heating water above it and creating steam. All right, and here we have an example of how the geothermal energy works. So we have water that is heated by the heat from the magma, and it's converted to steam. The moisture from the steam is, the moisture in the steam is kind of separated, and they spray the pressurized steam on the turbines and turn turbines to create electricity.